switch on off soon, okay, leaving to free fall to reach the surface of Mars. Okay, now they give us information. It starts from 460 to 75 by the parachute, the vertical motion. Then the speed reduced, okay, by the thrusters. The thrusters did not continue moving, so it keep falling from with a free fall. That's what they say, free fall, okay, until it reach the surface of Mars. The parachute was okay. شكرا للناس اللي عم تبعت لي مسجات على الواتساب. Okay, the thrusters was used to decrease, okay, in a height of how much? Sorry, the parachute was decreased in a height of 9.7 kilometers. That means 9,700 meters. Show that the average vertical deceleration, okay, it's supposed to be about 11. So what we're going to use? We're going to use the formula v square equal u square plus 2as. I told you we have to note how to use the equations, solve that. Okay, s is 9,700, u, which is, they give it to us 460, v, which is 75, okay, and they ask about the acceleration. By substituting the values here, 775 square equal 460 square plus 2, the acceleration that we want to find it out, multiplied by s, which is the displacement, okay, the displacement, which is 9,700. By using the calculator, the acceleration or the deceleration equal negative 10.6 meters per second square. Okay, so what we're going to do here, we show that the acceleration or the deceleration is equal to 10.6, which is 11 meters per second square. Then what they ask here, double I. The parachute was an angle 6 degrees from the vertical, not to scale. The total resistive force acting on the parachute, okay, and the prop was 6 degrees from the vertical. Calculate the magnitude of the average total resistive force. You may neglect the mass of the parachute itself. Now, since they say that we have an acceleration of about 11، دائما يا شباب صبايا ركزوا معي، لما يعطيني value هون، هذا الفاليو حنستخدمه بالnext part، اوكي، دائما هذا الفاليو احنا عندنا اياه 10.6، بس اذا ما اعطانا اياه حيكون هون لازم يعطينا اياه او بيكون error carried forward. فعشان هيك if I get the answer I will use my answer. If I didn't, I will get their answer. I will use their answer to answer the question. Okay? ماشي? So, now what are the vertical forces acting on the prop with the parachute? We have the weight and we have the resistive force. And as you can see, I put the resistive force longer than the weight because there is deceleration. It's fall down, okay, but with negative acceleration, which is deceleration, okay? So that means the resultant force equal mass multiplied by acceleration. The resultant force, which is the weight down minus the resistive force upwards, equal the mass, okay, multiplied by the acceleration or the deceleration that we just find it out. So the weight here, okay, now we have to know that this resistive force hello يعطيكم العافية. طيب, so it acts with an angle of 6 degrees. That means this resistive force has two components, one vertical and one horizontal. The vertical one, because this angle is close to it, 6, it's the adjacent, so R cosine 6, and this one, the horizontal, it will be R sine 6, and I'm not going to use it here. I'm going to use it because I'm talking about vertically. What is the resultant force act here? So weight, okay, which is mg 600 times 9.81 minus R cosine 6 degrees equal 600 multiplied by negative 10.6. By substituting the values, we can find that R equal approximately 869 in Newton, which is equal to approximately two significant figures, 8,690 or 8,700 watt in Newton. Good. How we get this answer? We get this answer by doing math. Okay. أنا آسف. Okay. So again, we have to realize that we have several forces here. As you can see, I'm not drawing on my picture, on my figure. I'm drawing my own picture, my own drawing. We have weight down, and we have resistive force in this direction, the air resistance with the friction force or the whatever it is. Okay. So the acceleration here. Okay. I'm sorry. شكرا يا حمزة. شكرا يا حمزة. Hamza remind us that the gravitational field strength on Mars is 3.8. I'm sorry, I was very fast here. شكرا يا شهد. شكرا يا حمزة. So yes, شكرا يا Amir also. The weight, which is equal to the mass multiplied by the gravity acceleration on the Mars, which is 3.8, the gravitational field strength on Mars. Okay, and don't forget to write the negative sign for the acceleration or the deceleration. Next, the prop was in a free fall from 3.7. How did you know that we have to use sine or cosine? Okay, now هذا الحكي هشرحه later on at the end of the session إن شاء الله. Okay, بس هلا أنا حكيت على السريع. We have a right angle triangle here. Okay, تمام. As you can see, this is the hypotenuse, our force. This is the adjacent, is the horizontal component, and this is the, okay, this is the opposite, and this is the adjacent is the vertical component. Okay, and the vertical component is the cosine. Okay, tamam. And while the one in front of the angle is the sine. Okay, the close, the adjacent is the cosine, and the in front of it, it will be the sine. Okay, tamam. Now, part B, the prop was in free fall, as they mentioned, okay, from 3.8 kilometer reached the surface of Mars of how much? 150 meters per second. So, as they say that here, it increased the speed from 68 to 150 in a free fall, okay? By how much distance? 3.6 kilometer. Explain whether the term free fall is correct in this context. Okay, your answer should include what? Calculation. 6 marks. So that. What is the distance here? 3,700. What's the initial speed? It's how much? 68. What's the final speed? 150. How much is the acceleration? We need to find it out, and we need to compare it with this value, the gravity acceleration of the free fall. If it's the same value or not. If it's not the same value, that means the free fall word is not correct. Okay, so which formula that we're going to use to find the acceleration? If I know S and U and V and know T, I will use the equation that's V square equal U square plus 2AS. Now V, which is 150 square, equal U, which is 68 square, plus 2 multiplied by the gravity acceleration on Mars that we have to find it out, or the acceleration of this part of this question. Okay, multiplied by S, the distance falling, which is 3,600 meters. And by doing that, okay, we will find out that the acceleration by using the calculator, it's 2.4 meters per second watt square. And this 2.4, it's less than 3.8. So that means, since the deceleration or the acceleration, since the acceleration is less than 3.8. So there are other forces act on it, not only its weight. Because when we said free fall, that means there is only single force acting on it, which is the weight. So it is not correct to say, free fall. When we say the free fall, that means only the weight acts on the object to make it fall downwards. But since it's not free fall, that means the resultant force is not equal